Jioni safu no la with whatever we do. Hale yide munyu skula. Nyepamne nekula. Nyepangi ragala gena. Nyepamne nekulukula. Ibuloke nungoto ni beti sola. Ibuloke dato ni betoto.
Mingi Congo.
Lamin.
Na?
Lamin ka jibe norin te nyame Lamin.
Ka bona wulo kono.
Wulo kono nyita mo Lamin.
Pabilenki.
Muna ngata afongole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumara kan kuma diten.
Fabrama.
Jumara mu.
Ndele bare muso.
Lunda mana. Jamani mbere.
Alindo ko.
Jamani.
Bari koto man kontande.
Bari jamani fana na mudu ma kontan.
Ngoto minaka ngala min de fon filitala. Lamin jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no bo mo lakko momo.
Ngoto.
Nam.
Itedinte alo ne Lamin hakilo diata bake karambugoto. Anu santeng ministry ko di ngole si suko na amake ko do holiday.
Sibitun.
Bagona ringa.
Ala ni ko kede namo balo.
Ande na ko na karta bulo be damna ala nije.
Ngoto.
Nam.
Ngoto mon kontan fere.
Jamani mu nekata.
Ifika Lamin ki wulo ko no nyinta mon ko do fete malo Lamin nyanta sila la be la moy kala karango.
Jamani karamol be sorande ne ko fasita wulo ko nako.
Karambugol ma soron. Iko karambugol soron da amake kom holiday lem. Ngoto. Dini ngo nyanta sila la ala karango la moy yamen kamen fue. Man kontan andamande. Allah
nyin kombo kurang adanda la kombo ndo la jan karamol soron da doro. Kamen kurang ma raro la kombo. E don dol fana na karamol soron je karamol soron Lamin adara ko ni no la amantara fe na sokon. Ala munekela
Lamin ite foyde malon ko lesinol be ke kar radio to.
Nga fine.
E ko nyana di mod Lamin.
Nga fine.
Ya muna fonye.
Bi kabin mina kan ntambita nteri maning Fatu.
Ha.
Ntambite la sukala ala dinngol bebe siri be la moyka.
Faru danso am fana tambita jele ni subala la ngaje dinngol be jet talanta nen kili waro. E be serin jele.
Sa Lamin farante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo Lamin.
Amandara fenela.
Ite dide ko ni man si yakari lesinol la moy radio to e balon na.
Muneka ke afonde ma nyara ni alon.
Cikot.
Afonde ma munebe ke.
Ite balon tel be cikirite. Ni man karambe ku kele. Yaje nata karana mbasa malaya ay tarije.
Bar nyarande kombo kurang ho findira kombo ide na raje den sonka bay ko Lamin ma nyata la wulo ko karamol be sonda afonde membe ke.
Ko to wole nati. Bawo ngalle ni Lamin kuntal. Kombo kurang o ka fa me kombo kurang asototal wala kinay ko e sisu wo kono. Bari ni ko e sisu wo kono ibe karangol di ke la radio lin telel to. Hani tel soto na man tel soto la bongo bar radio be bulan ko. Batiri sanga ay si ay alamo.
Sa do kala nyaadi.
Ko ta o bulaji.
Ado kala nyaadi.
Kamun ke nyaadi.
Radio abe wala mo la ibe mona falaje.
Ibe la karandirol kala jele.
Ti talle be radio ko men ka karande.
Ile subject ro baby jele. Baby jele.
Wala nanga chocho moy fa danse wolya. Ngombe tambi kana ngadi ngol de be ikadum bu ko de ko kala ma mo.
Asototal de.
Lamin mala be kara wala de.
Bari lafta alal ideal on ko inde every year second wala fourth.
Muna ni ko di ha ko de ko folle sinila ba ndele sinilo ne ba.
Mbasa mba foke nkoto. Wole fango ye ngulindi yalo famo keta bat yin fana bulata ko ko me yen nati jambi. Lamin nyanta karana ntel beji ko be nyineka. Ya bulay kara wulo kono ta kilar ya bambalo. Yo be bulaje nkoto dindi ngoy si ayala le sinol la moy radio.
Wora ka munda kara mo man soro Lamin nyanta kara si suwa na radio.
Lamin silale ayala le sinol.
Ndale ko korno ko smolong.
Kilar ya
mo be ngala ko momo. Sa mbi do ni kono kera.
Mengi bruzo.
Ndale ko do la ba rosa no radio ba no bari woro radio ni. Abe jele ba ngamra do man dembe buljan. Dala nyara nyar wora ko fendi mo la. Lamin tayra ba rosa.
Bara te ku folo ajibe nori nya labi tamete ku.
Mengi mun na re.
Teku.
Bari ko do famo ke.
Imagine nani nyambol. Si zol le keje kisigi man si zol. No le kabun ka nyo bari nyambu kino ni manya na kafindi. Ni nambe ko ni nambe ko so la ga.
Ngale limbeta de be nyambo do dilanna.
Nyara ni ko rin fennat. Nyara nata.
Bari famo ke da.
Ngata bun kono, tabi bun kono. Nyara ngando ko fele. Ko ke baru nganda ni pelo la ndija.
Iyo awa tar la
bun kono bismillah. Bisu diara.
Ye fongo tanka sina dolu tanka korota korota
Hello viewers and listeners, welcome to another lesson on mathematics. Today we are going to look at multiplication on simple equations with a single variable. Of course, this lesson targets students from 4 to grade 6. We've done equations in our previous lessons. We've done addition on equations. We've also done subtraction on equations, and now we are going to move on to multiplication on equations. In this lesson, we will see when we are given an equation and the operation there is multiplication, how do we isolate the variable by inversing the multiplication? How do we neutralize the multiplication in such a way that we are going to have the variable to stand alone? So before we go into the lesson proper, we will do the corrections of the tri-corrections that we are giving to you in the last lesson. That is on the subtraction on simple algebraic equations. So the first one we have, the first one was 93 minus x is equal to 64. 93 minus x is equal to 64. Now, if you can remember, during the previous lesson, if you are given a question wherein the variable is negative, you'll have to make the variable positive first before you go ahead with solving the question. Like in this case, we have 93 minus x is equal to 64. How many terms do we have here? We have 93 is a term of its own, negative x is a term of its own, and 64 is a term of its own. So in this case, our variable is negative, so we are going to make sure our variable is positive first. Now how do we do that? We'll have to add x on both sides. What we have is negative x on the right side of the equation, so we're going to add x on both sides of the equation to remove the negative x that we have. So just like the way you were told in the previous lesson, whatever you do on the right side of the equation, you must do the same thing on the left side of the equation. So here we are going to add x to both sides, which is going to give us 93 minus x plus x is equal to 64 plus x. What we have is 93 minus x plus x is equal to 64 plus x. So you realize that minus x and plus x will cancel. So on the right side of the equation, we are going to be left with 93 is equal to, you have 64 plus x. We're going to simplify that because they are unlike terms. So we are going to have 64 plus x. Now we've attained our objective in making the variable to be positive. Again, we want to isolate the variable. That's going to make that x stands alone. But in this equation that we have now, that is 93 is equal to 64 plus x. X is on the left side of the equation, and also we have 64 on the left side of the equation. So in order to make sure that x stands alone, we will have to undo 64. That is, we will remove 64. But as I said in other lessons, you cannot just erase 64 like that. So what we are going to do is, 64 is positive. What we have is positive 64. In order to undo positive 64, we'll have to bring in the inverse of it, that is negative 64. So that is to be done on the left side of the equation in order to make sure that we have the variable stands alone. But so long we are dealing with equations, whatever you do on the left, you'll have to do on the right side of the equation as well. So we are going to subtract 64 from both sides of the equation. That is going to give us 93 minus 64 is equal to 64 minus 64 plus x. What we have now is 93 minus 64 is equal to 64 minus 64 plus x. So here we know that positive 64 will cancel negative 64. So if you look at it on the left side of the equation now, we are left with only x. And on the right side, what we have is 93 minus 64. And 93 minus 64 will give us 29, which is equal to, on the left side of the equation, we are left with only x now. So we are going to have 29 is equal to x. So we can rewrite that as x is equal to 29. So what we mean here is that the value of x that will make this statement, this equation to be true, is 29. When we substitute 29 in the place of x, then we have 93 minus 29. The answer will give us 64. That is the first triquection. Then we look at the second triquection. The second triquection reads y minus 43 is equal to 19. Y minus 43 is equal to 19. Y minus 43 is equal to 19. Now let's look at this other equation. On the right side of the equation, we have y minus 43. And on the left side of the equation, we have 19. So we are solving for y. We want to find out what value of y can we have such that if we take 43 from it, the answer will give us 19. In doing so, we'll have to isolate the variable y. But if you look at the right side of the equation, we don't only have the variable y, we have y minus 43. So in a nutshell, we are going to undo 43 so that we can have y to stand alone. We cannot just erase 43, like negative 43 like that. So what we are going to do is, we will have negative 43. In order to neutralize negative 43 there, we'll have to add 43. But hence we are dealing with equations. Whatever you do on the right side of the equation, you'll have to do on the left side of the equation. So if we are adding 43, it means we are going to add 43 on both sides of the equation. So that is going to give us y minus 43 plus 43 is equal to 19 plus 43. Y minus 43 plus 43 is equal to 19 plus 43. From here, we know that 43 will take off 43. That is negative 43 plus 43 will give us 0. So on the right side of the equation now, we are left with y is equal to. Then we move to the left side of the equation. What we have there is 19 plus 43. And if you add 19 and 43 together, we are going to have 62. So y is equal to 62. What this simply means is the value of y that will make this statement true, the equation true, is 62. When we substitute 62 in the place of y, we are going to have 62 minus 43. And 62 minus 43 will give us 19. So that is it for the triquections. Today's lesson is going to be centered on multiplication on simple equations with a single variable. So we look at the first examples that we have there. The question reads, find the value of the missing variable in the equations below. Find the value of the missing variable in the equations below. The first one, we have 5 multiplied by a is equal to is equal to 45. 5 multiplied by A is equal to 45. Now let's look at this equation. First, we're going to look at the right side of the equation. The right side of the equation, we have 5 times A. 5 times A. And on the left side, we have just 45. So our aim here is to isolate the variable A. But the variable A is accompanied with 5 and multiplication. So 5 is multiplying A. In order to undo multiplication, as we discussed in some other lessons, in order to undo multiplication, you are going to use division. Just like on addition, in order to undo addition, we use subtraction. So here, if you want to undo 5, that is 5 times A, we'll have to divide by 5. So in this case, we are going to have 5 multiplied by A all over 5 and 45 all over 5. Remember, we are dividing both sides by 5 because we are dealing with equations. Whatever you do on the left side of the equation, you'll have to do the same thing on the right side of the equation so that the equation can remain balanced. So here now we are going to have 5 times A all over 5 is equal to 45 all over 5. So there we can see that 5 can cancel 5. That is on the right side of the equation. On the right side of the equation now we are going to be left with the variable A, which is equal to 45 divided by 5. We can equally simplify that. 5 goes into itself is once, and 5 goes into 45 is 9 times. So on the left side of the equation we are going to have 9, and on the right side of the equation we have A. So there we can conclude that A is equal to 9. What this simply means that is, when we look at our equation, that is 5 times A is equal to 9. We are looking for a number that can replace the variable A such that when you multiply 5 by that number, the answer will give you 45. We did the calculation and we realized that A is equal to 9. So when we put 9 in the place of A, if we multiply it by 5, that is 5 times 9, the answer will give us 45. So the value of A that makes this equation true is when A is equal to 9. Then we look at the second one. The second question reads 36 is equal to y times 3. 36 is equal to y times 3. Now let's look at the previous question. Our variable was on the right side of the equation, but in the second question our variable is on the left side of the equation. That simply tells us that let us not always expect the variable is going to be on the right, but it can be both on the right or on the left. So we are going to follow the same procedures. We'll have to make sure that we undo 3, that is times 3. Y is being multiplied by 3. We said we use division in order to undo multiplication. So y is multiplied by 3. In order to undo 3 there, we'll have to divide by 3. And whatever we do on the right side of the equation, we'll have to do the same thing on the left side of the equation. So we have, if you have multiplied by 3, you have to use dividing through by 3. So in this case, we are going to have 36 divided by 3 is equal to y times 3 all over 3. As you can see, we are dividing both sides of the equation by 3. So we look at the right side. What we have there is 36 divided by 3. So 3 goes into itself is once. into 3 is 1 time, into 6 is 2 times. So when we divide 36 by 3, the answer is going to give us 12. That is it for the right side of the equation. Then we move to the left side of the equation. What we have there is y times 3 all over 3. In this case, 3 will cancel 3. So on the left side of the equation, we are left with y. As you can see, we have 12 is equal to y. But we can rewrite that as y is equal to 12. What this tells us is the value of y that you can put in this equation to make the statement true is 12. If we substitute 12 for y and multiply it by 3, the answer will give us 36. So we move ahead to the other questions. In these questions, the instruction reads, find the value of the missing variables in the equations below. It is the same instruction like the previous questions. We are going to find the value of the variables that are given in each and every one of those equations. Like the first one we have, 9v is equal to 81. 9v is equal to 81. The second one we have, 64 is equal to 4p. We look at the first one, which reads 9v is equal to 81. Again, remember that 9v simply means 9 times v, which is equal to 81. So let's look at the right side of the equation. What do we have there? We have 9 times v. We want to isolate v. We want to make sure that v stands alone so that we can determine its value. But v is being multiplied by 9. In order to undo 9 here, because it is multiplied by v, we will have to divide through by 9. If you divide the right side of the equation, that will cancel 9. But we cannot only focus on the right side, we will have to look at the left side as well, because we are dealing with equations. Whatever you do on the left, you'll have to do the same thing on the right to make sure that the equation stays balanced. So we are going to divide through by 9, which is going to give us 9 times v all that over 9 is equal to 81 all that divided by 9. So as you can see, we've divided 9 on both sides of the equation. So we look at the right side of the equation, which reads 9 times v all over 9. So in this case, 9 can cancel 9. So now what we are left with on the right side of the equation is v, which is equal to, then we look at the left side of the equation. On the left side of the equation, we have 81 divided by 9. Here we can simply simplify that. 9 goes into itself is once, into 8 is cannot, so we're going to put the two together. Into 81 will give us 9 times. So v is equal to 9. Again, what this simply tells us is, when you multiply 9 by v, the answer gives us 81. So what value can you put in the place of v such that if you multiply it by 9, the answer will give us 81? When we calculate it, we realize that the value of v we have is 9. So when you put 9 in place of v, we'll have 9 times 9. And 9 times 9 will give us 81. That shows that our value as v equals 9 is the correct answer. 9 is the true value of v that makes this statement correct. Then we look at the second one, that is 64 is equal to 4p. 64 is equal to 4p. Now let's look at the left side of the equation. We have 4p. Again, 4p simply means 4 times p. So let's rewrite the question. We are going to have 64 is equal to 4 times p. Again, what we want to determine here is the value of p. And p is on the left side of the equation. P is being multiplied by 4. So we are going to undo 4 because 4 is multiplying p. So we are going to divide that by 4 so that 4 will cancel itself. But then we have to do that on the both sides of the equation. I'm doing this emphasis because when you concentrate on only one side, you are altering the equation. So that will not give you the correct answer. Whatever you do on the left side, you will have to do the same thing on the right side to keep your equation balanced. So here we are going to have 64. Remember, we are dividing through by 4 because we are undoing the 4 there. We are using division because 4 is multiplying p. So we are going to have 64 divided by 4 is equal to 4 times p all over 4. 4 times p all over 4. We've divided both sides of the equation by 4, so we can go ahead and simplify. On the right side of the equation, what we have there is 64 divided by 4. So 4 goes into itself is once, in the 6 is 1 time, remainder 2. The 2 and the 4 will give us 24, and 4 into 24 is 6 times. So on the right side of the equation we have 16 is equal to, then we move to the left side of the equation. What we have in the left side of the equation is 4 times p all over 4. So in this case, hence 4 is multiplying p, the 2 4s can cancel. So on the left side of the equation, we are left with only p. What we have now is 16 is equal to p. And we can rewrite that as p is equal to 16. We just found out the value of p that makes the equation true. That is to say, if we substitute 16 as the value of p in this equation, that is 64 is equals to 4p. If we substitute 16 in the place of p and multiply it by 4, the answer will give us 64. So that is it for that question. We move on to the other questions. All right, we move on to the other set of examples. Find the value of the missing variables in the equations below. All right, we look at the first question, which is 2p is equal to 12. 2p is equal to 12. Now if you look at the right side of the equation, what we have there is 2p, and 2p simply means 2 times p. So we are going to rewrite our equation. We are going to have 2 times p is equal to 12. 2 times p is equal to 12. Looking at the right side where we have our variable, we have 2 times p. In order to make sure that our variable stands alone, we'll have to divide by 2 because 2 is multiplying p. So the reason why we are dividing by 2 is because 2 is multiplying p. And if we are going to divide that by 2, we'll have to divide both sides of the equation by 2. This is going to give us 2 times p all over 2 is equal to 12 all over 2. So now we realize that on the right side of the equation we have 2 times p all over 2. Here we notice we can cancel 2 and 2. So on the right side of the equation we are left with we are left with P, which is equal to, then we look at the left side of the equation. On the left side of the equation, we have 12 divided by 2. And 12 divided by 2 will give us 2 goes in the itself is once, into 12 is 6 times. So 12 divided by 2 is equal to 6. Therefore, P is equal to 6. So the value of P that makes our equation 2P is equal to 12 correct is 6. So when we multiply 2 by the value of P, which is 6, it will give us 12. So 2 times 6 is equal to 12. Then we move on to the next question. We have 18 is equal to 6 cube. 18 is equal to 6 cube. If you look at it, our variable, which is q, is on the left side of the equation, and it is being multiplied by 6. So 6q can be written as 6 times q. So we are going to rewrite the question. That is to say, 18 is equal to 6 times q. Now we observe our variable is q and it is being multiplied by 6. So in order to make sure that our variable stands alone, we are going to divide through by 6. So we are going to divide the left side of the equation by 6 and the right side of the equation by 6. And again, the reason why we are dividing by 6 is to make sure our variable stands alone. That is q, we want it to be on one side of the equation. So we are going to divide through by 6. So this is going to give us 18 divided by 6 is equal to 6 times q divided by 6. We will look at the first side of the equation, which is the right side of the equation. We have 18 divided by 6. So we can simplify that. 6 goes into itself is once, into 18 is 3 times. So 18 divided by 6 will give us 3, which is equal to 6 times q all over 6. So here 6 will cancel 6. And there will be left with q on the left side of the equation. So what we have now is 3 is equal to q. We can rewrite that as q is equal to 3. So in order to have our equation to be true, the value of q has to be 3. That is to say, when we multiply 6 by 3, that is the value of q, the answer will give us 18. That is it for these two questions. Then we move on. So now we have the try questions. The first one, we have E, that is letter E times 2 is equal to 6. I repeat, letter E, that is E times 2 is equal to 6. The second one is 2y is equal to 18. 2y is equal to 18. So you're going to try questions. When we come back in our next lesson, we'll solve the questions together. For now, we leave you. Thank you so much for your attention.